Hello everyone, my name is Charlie, and recently there's been a lot of discussion on Veritasium's and Steve Moll's YouTube channels asking how on earth it's possible for a wind-powered machine to travel faster than the wind in the downwind direction. And that's what I'd love to show to you all today. Now, for the purpose of simplicity, I'm going to treat both the air and the ground as solid objects, with the ground being represented by this lower rack, the air being represented by the upper rack, and our wonderful wind-powered machine being represented by this compound gear. I'm about to move the air rack. What do you think will happen? 3, 2, 1... As you can see, our wind-powered machine does the impossible, traveling faster than the wind. But how did I arrive at this model? Well, if we didn't know the solution, but imagined that such a machine does exist, then from the perspective of that machine, the air must be traveling backwards. However, the ground must be traveling backwards even faster, which, as you can see, is very easily accomplished by a compound gear. And if it works from the craft's frame of reference, it must work from all frames of reference. Also, because gears are essentially continuous levers, another way of thinking about how this works is by treating the compound gear as a third-class lever, with the stationary fulcrum at ground level, the point of force application being at the air level, and the load being at the end of the lever at the center of the compound gear. Now it's obvious that if we move the lever at the point of force application, the motion at the load end is amplified. Another thing worth pointing out is that at any moment in time, the point on the craft in contact with the air is moving at the same speed as the air. Indeed it must be, because it's being pushed by the air. But how does all of this relate to the actual craft shown in Veritasium's video? Well, the wheels rolling on the ground are exactly like the lower rack and pinion gear. The shafts, gears, and chains inside the craft form a literal gear train, and the turbine acts like a screw through the air, converting linear into rotary motion, just like the upper rack and pinion gear. With all the connections made, we can now explain how the craft is able to travel faster than the wind. The wind pushes the turbine round, which then, via the gearing, turns the wheels round. And this is possible because even at the craft's maximum speed, faster than the wind, the turbine's linear screw speed is less than or equal to the wind speed. Just like the small gear's point of contact has the same velocity as the air rack. And I do call it a turbine, because it is only from the craft's frame of reference that it may seem like the blades are pushing the air backwards, when in fact we can see once again that it is the air that is pushing the turbines around, which in turn moves the whole craft forward. Wedges, like levers, are also analogous to gears. Therefore, we can use the same lines of reasoning to explain how a boat can sail faster than the wind, downwind. In the case of gears, linear motion of the wind was converted into rotary motion, which, after being multiplied, was converted back into linear motion in the axis of travel. In the case of wedges, we can convert the motion of the wind into motion of the boat perpendicular to the wind. Now I can add the lines of action, making the assumption that the hull cannot slip perpendicularly to this line in the sea, and that the sails cannot slip perpendicularly to this line in the air. Once more, the slopes, or multiplications, are chosen such that the sea moves backwards relative to the boat faster than the wind does. Now, using these same angles, but from the sea's frame of reference, we can see that the boat does in fact travel faster than the wind. Thank you very much for watching. I hope you found this enlightening, or can point out any glaring errors I've made. And remember to keep on pondering!